Here we go, here we go, here we go. All right, we getting a little deeper with that factoring of the trinomials. Now the A term is greater than 1. But I promise, we got this. How you doing? Welcome back to another episode of some crazy math we doing this year. But no worries. We got it. So last time we were together, we did factoring of trinomials where the A term was equal to 1. Now we're going to do some where it's greater than 1. And we're going to do two different types. So we're going to do one where there is a GCF that works and we can pull that out and you see what's going to happen. And then what happens in case you can't. All right, so let's take a look. Let's do it. So I have two examples here, right? Two separate examples. Here's the blue one. Here's the purple one over here. So let's just concentrate on the blue one here. Looking at these three terms here, okay? Thinking about a number, a value that they all have in common that I can factor out, right? They all don't have variables, so I don't have to worry about that. So I'm just looking at the numbers, right? And if you can see that they all have a 3 that I can factor out, then we go ahead and do that. By factoring out that 3 here, I'm going to be left with the x squared for that term. This term is going to be 10x, right? Factoring out that 3. And then I'm going to be left with a, I can't do math today. I'm left with a, oh Lord, I'm blanking. 16. Ooh, Lord, y'all, a 16 right there. And so the thing is, right, we're not done. Just this part right here can also be factored. So just like we did with our last one, because now we have a term, if we're just looking at what's in the parentheses, we now have an A term that is equal to 1. So let's go ahead and factor that, right? The first term here. And then factors of 16 that when I multiply them together, I get 16. But when I add them together, I get 10. What are you thinking? I'm going to go with 8 and 2. Hopefully you did the same. And then that would be our final answer. And here's an example where first, if you factor out the GCF, factoring the rest of the trinomial gets a little bit easier. All right, let's take a look at the purple one. You might already have it, right? What is a greatest common factor of these three terms? If you said 2, then we cooking with grease, friends. Let's go and do this now. So we got the 2 here. And that means we're going to be left with the x squared. Keep factoring. That's a minus 2x. Keep factoring. Plus 35. Now the A term is equal to 1, and it's a little bit easier for us to factor. Let's go ahead and set ourselves up. First term here is x squared, so x and an x. Then we got factors of 35. That when I multiply them together, I get 35, but add them together, get a negative 2. I'm going to go with a 7 and a 5. Placement of signs is important, friends. What are you thinking? If you got that, then you got that with me, right? Remember, friends, you don't have to wait for my pauses in my videos. You can always actually pause the video and try it on your own. I always recommend that. It's a great way to like quiz yourselves as you are doing this. And my videos, I try to tone it down so I don't go too long. So yeah, if you're watching these videos, just stop it when you see a problem. Try it for yourself. And if you get it right, that's great. Keep following the video. And if you don't get it right, keep following the video, right? There's no penalty for trying something. That's how we learn math. You learn more math and it becomes more cemented the more you mess up, believe it or not. Let's try this one. So here I wanted to give you one where the factor, where the GCF isn't just a number, right? It will include a variable. Take a look here. You probably are already eyeballing what's going to happen with the numbers, but take a look at those variables that also can be a part of this GCF. It actually is a part of this GCF, excuse me, which means I can factor out a 5x for all of these, leaving this term to be an x squared, this term to be a 6x, this term to be a minus 7. And then we can factor this. X, give me my factors of 7 that can work. 7 and 1. Be careful with your placement of signs. Think about those. And this is what you should get. Fully factored right there. So quickly. Let me show you an example of, because you're going to see it. One where it just doesn't work. Okay, so we can see quickly that the greatest common factor we have here is a 2. So you factor that out, b squared minus 9b minus 11. Now you can go for this, right? You can set it all up, and you're going to realize that the only factors you have for 11 are 11 and 1. And there's no arrangement that you can make this happen so it comes out to be a -9. That's just not going to work. So that means this is your final answer. And sometimes, friends, after you find the GCF, that is just your final answer. That is its fully factored, simplified form. Okay? Now, last section. Let's take a look at one where you just don't have a GCF. There's no variables that they all have all have in common. No, that's not there. And check it out. I can't pull out a number. So that means you go right to the factoring. And you still think about it the same way. What 2 terms could I put here that could make 2x squared? Well, I know that x times x will give me x squared, so that means one of these has to be a 2x and the other has to be an x. These are the factors for 2x squared that can work. So this has to be in this place. Okay. And then you think about your factors of 15 that could work here that I can multiply together to get 15. But hold on, because this 2 is sitting here, and I'm telling you the 3 and the 5 are going to be your factors. But the placement, because of this, is going to be very important where you put that 3 and that 5. So for example, let's do it the wrong way. If I put 5 here and 3 here, and I do this, if I evaluate that, I won't get this, right? If I get so 2x times x is going to give me 2x squared, yes. And then 2x times 5 is going to give me 10x. 3 times x is 3x plus 15. You can already see, right, it's going to be too big. But just by switching them, y'all. 2x times x is 2x squared plus a 6x plus a 5x plus a 15x. It works. Placement becomes just a little bit more important. This is what happens when sometimes the a is greater than 1 and you can't just factor it out. Let's try another one. Y'all doing great. You're doing great. I'm going to do 2 more and then I'm going to let it go. Okay. Again, there's no GCF that you can factor out here. So again, you already know, you're just going to keep going for it. You're going to set it up. What 2 factors can I use to multiply together to get 2x squared? You guessed it, 2x and x. What factors for 6 can work for this? 1 and 6, 3 and 2. If it's 1 and 6 or 3 and 2, where are you placing them? Now, this might take a little trial and error, and that's totally fine. But try it. Like, legitimately pause this video, y'all, and just try that. Try and see if you got the settlement or the placement of them correctly. Well, I'm going to go here. 6 and 1 for the factors of 6. And that works because 2x times x is 2x squared. That's going to give me a 1x. That's going to give me a 12x. 1 plus 12 is 13. Here you go. One more. Let's do one more. Now, this is probably one of the more complicated ones, right? Because now I'm giving you a term where it's not prime. So you might want to say, well, okay, I'm thinking, Mr. Bertrand, that I want to do 2x and 2x because 2x times 2x will give me 4x squared. Okay, then you're going to have to do a little bit of work here, right? And since these are the same, just play with the factors of 6. So we tried the factors of 6, right? 3 and 2. And it doesn't matter where I put the 3 and 2 because these both are 2x anyway. So if it's negative, then I let's say I make this one negative, this one positive. So multiplying those gives me that negative 6, but that'll give me a negative 6 and a 4. That doesn't work. So you might even want to go back and try it differently. You might want to say, okay, I'm going to switch the signs. Notice the process of what I'm doing. This is exactly what I'm expecting you to do as you're working through these problems. Again, that's still going to give me my 4x squared. This is going to give me plus 6x. That's going to give me minus 4x. That's not going to give me to that 5x. You see what's happening? So I'm going to save you a headache here, right? Because then you would try it with the 6 and the 1, those factors. That doesn't work in this case. In this case, we're going to do it the same way we did the other ones. So knowing that there's no factor here, and believing that we already tested the 2x ones, right? The 2x didn't work. These are the only other factors that we can try. And now we go into it. And so then I would do the same thing again. I would test my factors for my 6. I'm going to try 3 and 2. And I'll make this negative and this positive. And just test it out. 4x times x, 4x squared, 3x, minus 8x, minus 6. And yep, 3x minus 8x. Oops, actually, I got my signs backwards. So that lets me know it should be this. So I get a negative here and a positive here to get the positive there. And I really wanted to show that process because that's how much that could take, right? You need to take your time combing through your factors, figuring out placements, figuring out signs, right? And then just testing it out, always going back and checking your work. This is one of those exercises where you can't just put it down and not look at and reevaluate how you got there and like re-plug everything back in. Like you have to check your final answers to make sure that they work right. So as always, give it a shot. Check out the work and ask questions in class. And then, yeah, I'll see you soon.